Welcome back. We have learned that neural networks are built from functions and our single neuron uses linear functions. But there's a critical problem we need to address. What if instead of smooth, continuous outputs, our neuron made sudden dramatic decisions? What if it was either completely on or completely off with no middle ground?
You like donuts, Homer?
Yeah.
What about vegetables?
Yeah.
Not everything is black and white, Homer.
But Marge, my brain is a perceptron.
Today we are exploring the perceptron problem. Why step functions and sudden jumps create serious issues in real-world applications. This will show you exactly why we need smoother, more sophisticated approaches. A perceptron is the simplest type of artificial neuron, invented in 1943. Here's how it works. Take input, just like our regular neuron, multiply by weights and add bias. But here's the key difference. Apply a step function. The step function works like this. If the sum is above a threshold, output equals to 1, that is on. If the sum is below a threshold, output equals to 0, that is off. Mathematically, it can be represented as f of z equals to 1 if z is greater than equals to threshold. F of z equals to 0 if z is less than threshold. Look at this graph. There's a sudden dramatic jump from 0 to 1. No gradual transition, no middle ground, it's either completely off or completely on. This might seem reasonable at first, after all many decisions are binary, but let's see why this creates problems. Let's use a concrete example, email spam detection. Our perceptron looks at three features: number of promotional words like free, urgent, etc., number of suspicious links, sender reputation score. Email A, 5 promotional words multiplies by 0.3 equals to 1.5. 2 suspicious links multiplied by 0.4 equals to 0.8. Reputation score of 7 multiplies by minus 0.2. That will be minus 1.4. Total will be 1.5 plus 0.8 minus 1.4 equals to 0.9. If our threshold is 1, score of 0.9 will give us the output of 0, not spam. The email goes to your inbox. Now let's imagine the next example. That will be email B, almost identical but a bit of change in the values. 5 promotional words multiplies by 0.3, that will be 1.5. Here we will have 2 suspicious link multiplies by 0.4, that will be 0.8. Reputation score of 6.5 multiplies by minus 0.2, that will give us a minus 1.3. Total will be 1.5 plus 0.8 minus 1.3, that will be 1.0. So here score is 1.0, so our output will be 1, that will be spam. The email gets blocked. A tiny change in reputation from 7 to 6.5 caused a massive change in decision. This doesn't reflect reality. Email spamminess isn't just an on or off switch. This sudden jump problem appears everywhere in real life. House prices don't suddenly jump. A 1,999 square feet will cost you $370,000. A 2,001 square feet house will cost you $370,300. The difference should be gradual, not a sudden $50,000 jump. Medical diagnosis isn't binary. Slightly elevated temperature will give you slightly higher illness probability. Very high temperature, much higher illness probability. It should be a smooth transition. But here's the biggest issue for machine learning. How do you learn from mistakes? With a step function, if you are wrong, how do you know which direction to adjust? The function is flat everywhere except at the jump. There's no gradient to follow for improvement. This is like trying to find your way home in the dark with a flashlight that only shows you sudden cliffs but no gentle slopes to guide you. Instead of sudden jump, imagine a S-shaped curve. Low inputs will give you output close to 0, medium inputs output around 0.5, and high inputs will give you output close to 1. But it transitions smoothly. The smooth S-curve exists and it's called the sigmoid function. It gives us probability-like outputs between 0 and 1, smooth transitions, gradients we can use for learning. The same email that scored 0.9 might output 0.48, probably not as spam. The email that scored 1.0 might output 0.52, probably as spam. Much reasonable, right? So let's recap the perceptron problem. Step functions create sudden, unrealistic jumps. Tiny input changes cause massive output changes. There are no gradients to guide learning. Real-world decisions are usually gradual, not binary. The solution we need: smooth, S-shaped functions that gradually transforms from 0 to 1. In our next video, we will explore the mathematical function that makes this possible: exponential and logarithmic functions. This will give us the tools to create the perfect S-shaped curve we need. Thanks for watching this video, and I will see you in the next video. In our next video, we will explore the mathematical functions that make this possible: exponential and logarithmic functions. This will give us the tools to create the perfect S-shaped curve we need. Thanks for watching this video, and I will see you in the next video where we will build the mathematical foundation for smoother learnable functions. Thank you. Bye.